I would rather take your class than Miss Durkee.
So here we go.
Miss Durkee did not like me.
Nope.
She don't like no one,
She likes me.
especially Thomas.
I taught her how to stand up.
Miss Evans doesn't like Thomas either.
Okay,
Nobody likes Thomas.
let's just
Racial jokes.
leave it be. All right, so we left off last week with ionic bonds and the compounds that they form. And you guys are really good at identifying like the chemical formula. So from the ions, those superscript charges, those become the subscripts that become the numbers in our chemical formula. All right, and so you guys did that very well. There's really nothing on slide 15. So we're gonna go to 16 here. The last thing with ionic compounds we have to talk about is naming them. And we kind of hinted at this, and so now we're getting kind of the actual like note part. And then we're gonna do some more practice. So, naming ionic compounds. We know that these compounds form between our metal cation and our negative anion nonmetals. Remember, the cation has the T kind of looks like the plus sign. So hopefully you're remembering that the cation is the positive one. So we're going to write the name of the positive ion, our cation, that metal first. Yes?
We have a blank on slide 14, the last one.
Oh, we do? Oh, shoot, we do. I forgot that I didn't click that. Thank you. 14.
That was my bad, to be completely honest.
No, I did not click it. I forgot that there was another. The compound itself is neutral. Thank you very much. Compound itself is neutral. And I did catch that when we did it, like by the end of the day, but I didn't make that click for the morning classes. So my fault. All right, we talked about it, but good. You don't want to have that not in your notes, so thank you. Okay, so we write the name of the positive ion first. Next thing, you write the root name of the first part of the ion. All we mean by the root is like the beginning part. So ox, salt, phos, right? So basically you drop the ending of the oxygen and the sulfur and the nitrogen and the iodine. You drop that ending and then you add IDE to it. And that's it. That's how you do it. So we do not need subscripts for ionic compounds unless we have the metal that has multiple versions of itself, like for the transition metals sometimes. But we're not really going to look at those. Those are kind of the exception. And so we're not going to look at the exception. We're just going to learn the general rules. And that's it. You just list the first one, like sodium, and then let's say you were combining that with chlorine. Well, you just say chlor and then add ide, so chloride. So we get sodium chloride. And having it that way lets everybody know we're dealing now with the compound. We're not dealing with sodium and chlorine by themselves as neutral but unstable elements. We're now looking at them as sodium and chloride, this brand new compound that is charged, right? The individual elements are charged, they formed ions, that's why they're attracting to make this new compound, right? So it's just a way to kind of like let us visually or like see it written and hear it as a new thing, not as exactly the same as the individual pieces. So sodium chloride would be the new name. Oh, dang. I didn't realize that was our first example. Okay, so sodium and chlorine, we said, would be sodium and chloride. Whoa, sorry. All right, so BeO. What do you think we would call that? What is Be? Beryllium. And what's the O stand for?
Oxygen.
Oxygen. So how would we make that our new name as that new ionic compound? Nevaeh, what do you think? Beryllium oxide. Okay, so go ahead and make sure you have those filled in. Beryllium oxide. Don't worry too much about the spelling. beryllium oxide. We're gonna come back and do some more practice here in a minute, but there's a few more slides to kind of wrap up and finish ionic compounds, so I wanna do that. And then we'll come back and get to the naming practice. All right, so a lot of times ionic bonds are gonna look like a crystal lattice work type arrangement where you're alternating positive and negatives because they're attracting, right? Opposite charges attract. So you're getting an attraction here and here and here and here, and it's kind of coming three-dimensionally all around. So if you think of like a grain of salt, it's kind of like a tiny little cube, right? And the reason why is because the sodium and the chlorine actually do physically arrange just like this, right? So it gives you like this nice predictable kind of arrangement. And most of the time these form brittle solids, just like a grain of salt again. And it's the smallest ratio of positive and negative ions that make up our formula. Basically, it's the reduced version. So if this is sodium chloride, right, you could have 1,000,000 sodiums and 1,000,000 chlorine atoms, and they could combine. But we don't write Na1,000,000, Cl1,000,000 in our formula, right? That'd be weird. We reduce it, since it's 1,000,000 to 1,000,000, it reduces to a 1 and 1, which is really just sodium and chlorine. Okay, and so if we have, a formula where we're dealing with like something that has a subscript of 4 and something that has a subscript of 2, you'd have a 4 to 2, but that's not in the simplest form. We could really reduce that to a 2 to 1. As long as the ratio stays the same, a 1 to 1, a 2 to 1, maybe a 3 to 2, whatever it may be, that's fine. You could have any version of that ratio. So you could have 6 and 4. You could have 9 and 6, right? As long as you have that same ratio, that same proportion, it's representing that same formula, all right? But we're always gonna try to keep it in the simplest form. All right, and so the ionic bonds form this lattice-like structure because we have those oppositely charged ions. Ions make ionic compounds and bonds. And you can see it three-dimensionally, the attraction, like those opposite charges being able to kind of hold it, and that's why it forms that kind of cube or perfectly rigid set structure when they actually combine in real life. Okay, and it makes the structure three-dimensional because of it. One more. Nope, stop there at 18. Okay, so now we're gonna go, and these links are in Google Classroom for today. So if you're absent, make sure you practice some of these. We're gonna do